Algebra 2, homework, section 4.2. Tonight, we are looking at standard form quadratic equations, and we're finding the axis of symmetry, the vertex, whether it's a max or min, up, down, x-intercept, domain, range, and we're graphing them. So we start off by finding the axis of symmetry for problem number 1, which is x equals the opposite of b over 2a. Well, b in this problem is 2, so it's going to be negative 2 over 2 times negative 1. So negative 2 over negative 2 is 1. So your axis of symmetry is the line x equals 1. So we're going to graph x equals 1. And then we're going to plug 1 into your equation to find the vertex. So when you plug a 1 right here, you have negative 1 times 1 squared plus 2 times 1 plus 1. So 1 times 1 is 1 times negative 1 is negative 1 plus 2 plus 1. So I get 2 for this. So 1 comma 2. That's your vertex. So I'm going to put a dot at 1 comma 2. This one's going to be going upside down. So our vertex is going to be a maximum point. The y-intercept is 1, so 0, 1. So we can put a dot at 0, 1, which means you're going to have another symmetrical point over at 2, 1. Now, you're going to need more points than that. So I would plug in either a 3 or a negative 1 into your t-chart. Let's do negative 1. Plug negative 1 in here. Negative 1 squared is 1, and 1 times negative 1 is negative 1. Then plus 2 times negative 1 is negative 2, and then plus 1. So you're going to get negative 2 for an answer. These cancel right out. So over 1 down 2, which means you can go this way down 2. Connect your dots, and that is a picture, nice picture of your parabola. What is the domain? We said is all real numbers, and the range is going to be y is less than or equal to, it's the y value here, which is 2. Number 2, we need the axis of symmetry. So again, negative b over 2a. So it's negative 4 over 2 times 2. 2 times 2 is 4. So negative 1 is your axis of symmetry. Okay, so you're going to plug negative 1 into your equation. Negative 1 squared is 1. 1 times 2 is 2. Negative 1 times 4 is negative 4. And then minus 7. So this is negative 11, and 2 is negative 9. So negative 1, negative 9 is your vertex. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's your vertex. Your y-intercept is negative 7. So I could plot that point and then plot a point that's symmetrical across. So you have 3 points so far. This is going to be going up, so our vertex is going to be a minimum. Your domain is all real numbers, and your range is going to be y is greater than or equal to negative 9, because it's going up. Now, we should probably plug in, do another point. 3 is not enough. Let's plug 1 in. So if we plug a 1 in here, 1 squared is 1. 1 times 2 is 2. 2 plus 4 is 6. And 6 minus 7 is negative 1. Here's your graph. Next. Negative b over 2a again. So we have negative 4 over 2 times negative 2. And again, you get 1. So your vertex is going to be 1. We need to plug 1 in here. So we have 1 squared is 1 times negative 2 is negative 2. plus we have 4 times 1, which is 4, and then plus 5. So we have 7 is our vertex, 1, 7. So let's graph our axis of symmetry, which again is 1, x equals 1. Our vertex is 1, 7. 1, 2, 3, 4, 5, 6, 7. Our y-intercept is 5. So it's this point right here, which means we have that one. So y-intercept 0, 5. This is a maximum vertex. This is going down. And our domain is all real numbers, and our range is y is less than or equal to 7. So what you're going to want to do is pick a point. I'd pick maybe not 1, not 2, but 3. Let's try 3. If we put a 3 right here, 3 squared is 9. 9 times negative 2 is negative 18. And then plus 4 times 3 is 12. And then plus 5. Well, 12 and 5 is 17, so you end up with negative 1 here. And there we go. Done. On the back side. All you have to do for these ones, we are going from standard form to vertex form. So we need our vertex. We need to find out what the vertex is for this one. So you're going to use negative b over 2a. So if b is 2, opposite is negative 2, and a is 1. So 2 times 1 is 2. So x is negative 1. So then you're going to plug negative 1 right in here. Negative 1 squared is 1. And 1 plus 2 times negative 1 is negative 2. And then plus 5. So you end up with 4. Okay? So your vertex is negative 1, 4. So how do you write this in vertex form? It's y equals, we need the a value, which is 1, and then x plus 1, you do the opposite of this, squared plus 4. For 5, x equals negative b over 2a. So instead of negative 4, we use a positive 4, over 2 times 2, which is 4, so we have a 1. We're going to plug a 1 here. So 2 times 1 squared is 2, minus 4, and then plus 3. So this is negative 2. Negative 2 plus 3 is 1. So our vertex is 1, 1. So in our a value, we need this a value, which is 2. So your equation is y equals 2, parenthesis x minus 1 squared plus 1. Next one, number 6. X equals negative b over 2a. So we have negative 6 over 2 times negative 1, which is negative 2. So x is 3, and then you're going to plug 3 in here. 3 squared is 9, so it's negative 9 plus 18, and then minus 5. So that's 9, and 9 minus 5 is 4. So our vertex is 3, 4. So our equation is going to be y equals the a value is negative 1, and then x minus 3 squared plus 4. Number 7, x equals negative b over 2a. So it's negative 4 over 2 times negative 2, which is negative 4, so 1. We're going to plug a 1 in here. 1 squared is 1 times negative 2. 4 times 1 is 4, and then plus 6. So this gives us 10. 10 minus 2 is 8. So our vertex is 1, 8. So we're going to write y equals, the a value is negative, always pull the a value out. So x minus 1 squared plus 8. Number 8, x equals negative b over 2a. So if b is 12, you're going to put a negative 12 on top, and then 2 times 3 is 6, so it's negative 2. We're going to plug negative 2 in here. Negative 2 squared is 4, and 4 times 3 is 12, and then 12 times negative 2 is negative 24, and then minus 4. So this gives us negative 12. Negative 12 minus 4 is negative 16. So our vertex is negative 2, negative 16. So the equation is going to be y equals a value 3 and then x plus 2, opposite of this, and then minus 16. And for number 9, x equals negative b over 2a. So we have 16 opposite of a. B is going to be a positive 16 over 2 times 4, which is 8. So 2 is our x value. You're going to plug 2 in here. 2 squared is 4. 4 times 4 is 16, minus 32, and then plus 2. Negative 16 plus 2 is negative 14. So this equation is going to be y equals the a value is 4, and then x minus 2 squared minus 14. Okay, now these last 3 are a review of yesterday's homework. How do you graph this? Well, you start off with your parent function, which is, sorry, we ran out of little box there, negative 2, negative 1, 0, 1, 2. So you have 4, 1, 0, 1, 4. So the first thing you're going to do right here, you're going to add 3 to your x values. So taking all of these and adding 3. If you added 3, you get 1. Add 3, you get 2. Add 3, you get 3. Add 3, you get 4. Add 3, you get 5. Keeping these the same. So 4, 1, 0, 1, 4. The next thing, this negative 2, you multiply the y values by negative 2. So keeping the x values the same, 1, 2, 3, 4, 5, you're going to multiply these y values by negative 2. So you get negative 8, negative 2, 0, negative 2, negative 8. And the last thing you're going to do is you're going to add 7 to the y values. Add 7, keep your x values the same, 1, 2, 3, 4, and 5. Adding 7 to your y values, you're going to get negative 1, add 7, you get 5, add 7, add 7, add 7. You should see a pattern here. Now let's graph this. Over 3, up 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 2, 5. 1, 2, 3, 4, 5. And then we have 4, 5. And then we have 1, negative 1. And, oops. And we draw our smooth curve with arrows at the end, and let's label all this information. Our vertex is 3, 7. Our axis of symmetry is the line x equals 3. This is going to be a maximum value, your vertex. Your domain is all real numbers, and your range is y is less than or equal to 7. Number 11, you need to write the equation of this quadratic function. So we need 2 things. We need the vertex. This vertex looks like it's negative 4, 2. That's your h and your k. And we've got a point I can see right here is 0, negative 6. So we're going to write y equals a x minus h squared plus k. So what goes in the x and the y spot is this ordered pair. So you're going to put negative 6 here for y and 0 for x. Your h and your k, you're going to put a negative 4 here, so this is going to be a positive 4. And the 2 goes here. This is h and k. So we need to evaluate this for a. So 0 and 4 is 4. 4 squared is 16. So you have 16a plus 2 equals negative 6. Subtract 2, you get negative 8. And a is negative 8/16 or negative 1/2. So now we're going to use this a value and put this back in here along with the vertex. So you get y equals negative 1/2 and then x plus 4 squared plus 2. That's your equation. For number 12, it's the same type of problem, except for we give you the vertex, which is your h and your k, and your x and your y. So you go right into y equals a x minus h squared plus k. So 4 is your y value. 4 equals, we don't know what a is, x is 9, 9 minus 3 is your h value, and then plus 7. So let's evaluate this for a. 6 squared is 36, so you have 36a, plus 7 equals 4. Subtract 4, you get 3, negative 3, and you get 36a. Divide this by 36, so a is negative, reduce it 112. That's your a value. So now you're going to use this a value to write the equation. I'm going to do it here. Negative 1/12, and then plug in your vertex, which is 3, 7. So it's x minus 3. Don't forget to square that quantity, and then plus k. And that is your final answer.